something else. Oh, yeah. I just wanted to point out to all of you all that on Canvas, I just posted some final exam materials. So obviously the practice final from your class. There's also the final review from the other class, which is literally just like 30 pages of here's a bunch of practice problems that cover all the things. If you're looking for more practice, that's probably, I would say you should obviously look at his practice exams first, because that's most likely to be what your exams going to look like. But if you're looking for more, there's the final review problems from Alameda. There's also a final review from me and solutions to it. Not that I actually wrote them, but they're from one of my coworkers. And that's another good source of practice problems if you're looking for more practice. The other thing I was going to say, I forgot to bring the QR code. So please fill out the attendance form when you have a moment. I'm sure you can find the link to it in Canvas or somewhere. Other thing, when you have a chance, if you haven't already, please fill out this survey course evaluation for this class. It's in Canvas, the top link there. It probably takes just a few minutes. We do read those results eventually. They are anonymous, but I do like to see what people have to say. So please do fill it out when you have a chance. I think that's all I got. So my plan today was to go over the practice final that he posted. I think it's worth looking at and kind of talking about how we would answer questions like this and what we need to be thoughtful about. And this is for Casals. So let's start at the very beginning. And definitely let me know if you have questions along the way. So this first one says, consider the function f of x equal to the natural log of 1 plus x squared times cosine of 4x. And the first part is compute the Taylor series of just cosine of 4x, right? So definitely be careful reading this, right? I could see not paying attention to the question very carefully and just seeing, oh, here's the function, do it for that. So read the questions carefully as usual. So here's the work I would show for doing this. I would write cosine of x equals, I might write out some terms, I might not. You could write out terms like 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, etc. And then it's going to be the sum from n equals 0 to infinity of x to the 2n over 2n in parentheses factorial times negative 1 to the n. And then all I think you have to do for cosine of 4x is just say, well, then cosine of 4x is going to be 1 minus 4x quantity squared over 2 factorial plus 4x quantity to the 4th over 4 factorial, which is equal to the sum from n equals 0 to infinity. We're just replacing the x with 4x to the 2n, 2n factorial times negative 1 to the n. And to me, that seems like it'd be sufficient work. I don't think the intention here is for you to find a bunch of derivatives and do it that way. Also, it is kind of, it's kind of necessary. It's definitely necessary in a later part of this problem to kind of know what the first few terms of cosine of 4x are. So I would definitely write this out here. I'd probably write another term here. And then they're saying, the next part here, justify why the Taylor series of the natural log of 1 plus x squared centered at 0 is this. So here's my take on it. My take on this is you should never be using the long version of Taylor's formula unless you have to. And you don't have to here. To find what natural log of 1 plus x squared is, we could say, well, the derivative, yeah. Probably, yeah. The only exception typically is like if you're talking about natural log of just x. That's centered usually at 1. You can't center it at 0 because natural log of 0 is undefined. But yeah, usually at 0. So I would take the derivative of this and say derivative of natural log of 1 plus x squared is 1 over 1 plus x squared times 2x, which I'm going to then think of as 2x times 1 over 1 minus negative x squared. Because I know a Taylor series for 1 over 1 minus some stuff. That's just or really, you can even think of it as 2x over 1 minus stuff if you want to do kind of first term. So that might, you could go kind of either way. You can either think of it as 2x over 1 minus x squared, and then say, okay, well, that's just a geometric series. My first term is 2x. What's my ratio? Negative x squared, right? It's your first term over 1 minus your ratio. So my next term is going to be 2x times negative x squared. And my next term is going to be 2x times negative x squared squared. And my next term is going to be 2x times negative x squared cubed. And so on and so on and so on. So we can write this in, and I do want to write this in the summation because I want to then take the antiderivative of it to get back to the natural log. So I'm going to write this as the sum from n equals 0 or n equals 1. I think I want to start at n equals 1. I'm going to do 2x. No, I think n look. So I'm going to write the formula first and then figure out what n I need to start at. I'm going to do 2x times negative x squared to the nth power. And then I do need to start at n equals 0. We're going to want to anti-differentiate this to get back to the function we started with. Before I do that, I really should simplify this so I kind of have just x to the whatever by itself, because that's the only part we're actually going to anti-differentiate. The rest of it's just a constant as far as x is concerned. So here, I'm going to write this as the sum from n equals 0 to infinity of 2x times negative 1 to the n times x to the 2n. And then combining the x's, I can write this as the sum from n equals 0 to infinity of x to the 2n plus 1 times 2 times negative 1 to the n. So 2 times negative 1 to the n times x to the 2n plus 1. And then finally, the antiderivative. So my antiderivative, my natural log of 1 plus x squared, is going to be the antiderivative of what we just found. Which if we anti-differentiate x to the 2n plus 1, we're just going to get sum from n equals 0 to infinity of 2 times negative 1 to the n times x to the 2n plus 2 over 2n plus 2. And then I would start writing out terms to make sure it actually looked like the thing it was supposed to look like. So if I plug in n equals 0, I get 2 times 1 times x squared over 2. Great. 2 times x squared over 2 is exactly x squared. And then when I plug in n equals 1, I get 2 times negative 1, so minus 2 times x to the 4th over 4, which is exactly x to the 4th over 2. So we're looking good. I would probably just kind of fake it the rest. I would probably just say the next one's going to be x to the 6th over 3. The next one's going to be minus x to the 8th over 4. I think that'd be probably okay to do. Oh, but actually, so I should point out, this formula I've written here and this formula he's written here are the same. They just look a little different. Are they the same? Oh yeah, they are. Yeah. I could have done a little bit more simplifying here. I could have written the 2 over 2n plus 2 is just a 1 over n plus 1. I factored out the 2 from the bottom and canceled it. That probably would have been good to do. But I will point out we are starting in slightly different places, but they're still the same series. Is it okay to leave it like this? That's a good question. I don't have a good answer. It might be okay to leave it like this. I think it's okay to leave it like this. I know it's the same series, but I don't know how the grader might feel about that. Questions about what we've done here at all? There are other ways to do this, right? You could have gone the long way. I don't think that's what he wants you to do. I think he wants you to take the derivative and then find the series for the thing we know and then anti-differentiate it. But there are lots of ways to solve a problem in class, so it's kind of up to you.
Do you always derive?
You don't always derive, but so here's my thought, which is typical. When you're trying to find a Taylor series for something, you're trying to use something you already know. You're trying to make it look like e to the x or sine of x, or I should say really e to the something, sine of something, or cosine of something, or 1 over 1 minus something, because those are all things that we know the Taylor series for, right? Or we should know the Taylor series for right off the top of our head. So I saw that when I took the derivative of the natural log of 1 plus x squared, I was going to get 1 over 1 plus x squared times 2x. And then the 1 over 1 plus x squared, to me, that's looking like, oh, 1 over 1 minus some stuff. And I know that's that's what the geometric series adds up to. Other questions about this? Okay, let's look at the next part. We can always come back to this. Find the radius of convergence of the Taylor series in part B. Okay, so there's a couple things you could say here. You could just do it directly. You could use the ratio test. So one option would be to use the ratio test. And say, okay, I'm going to look at the limit n goes to infinity of the absolute value of an plus 1 over an, which is going to be the limit n goes to infinity of, so yeah, of course. Sorry, thank you. I should probably, we could use either one. We could use the one that we found, or we could use the version that he has. They're really the same thing. Let's go ahead and use the one we found. I should simplify this a tiny bit. I should really think of this as the sum from n equals 0 to infinity. The 2's cancel, and you really get -1 to the n times x to the 2n plus 2 over n plus 1. Pretty much the same thing he has. I'm just starting at 0, and he's just starting at 1. So we have to adjust. So doing it this way, we've got the limit as n goes to infinity of the absolute value -1 to the n plus 1 times x to the 2 times n plus 1 plus 2. So 2n plus 2 plus 2 is 2n plus 4 over n plus 2, and then times the reciprocal of the thing we have. So n plus 1 for -1 to the n times x to the 2n plus 2. And in my opinion, you can do all the simplifying here in one shot. X to the 2n plus 4 over x to the 2n plus 2 is going to be x squared. We still have the limit, then goes to infinity of the absolute value of x squared. The -1 to the n plus 1 over -1 to the n doesn't really even matter. I think you can just not write it personally. But if you feel like you need to write it, you can say I have it times a -1. And then we have times n plus 1 over n plus 2. So that ends up being just, well, the n plus 1 over n plus 2 goes to 1. We take the limit, so the absolute value of -x squared, which is the same as the absolute value of +x squared. We want that to be less than 1 as ratio test. So then we get x squared has to be between 1 and -1. So we get that the x is between 1 and -1. And so our radius is equal to 1. Alternatively, we could have said, well, if we look back, no, I feel like this is probably the way you want to go. You could have said something about how the radius of the derivative series, like this series here, the derivative of the natural log 1 plus x squared, has a radius of 1 because we know it's geometric. And so the ratio has to be between -1 and 1. And then when you take derivatives or anti-derivatives of series, the radius of convergence doesn't change. So that's another way you could have argued that the radius is 1. But I feel like the ratio test is more of a sure thing. You always know how it works. It's easy to apply. Okay. The last part of this question, I think it's the last part. Argue that the Taylor approximation of order 7 of f of x at a equals 0 is this. Okay, so let's remind ourselves f of x is natural log of 1 plus x squared times cosine 4x. And what I really think he wants you to do here is just write out the terms and multiply stuff together. Right? There's definitely not we shouldn't be taking any derivatives of this, right? That's not the intention. We just want to say, well, this is going to equal the natural log of 1 plus x squared. And I do think you should write out the terms the long way, not using a summation. The natural log of 1 plus x squared was x squared minus x to the 4th over 2 plus x to the 6th over 3, ... I would write more terms, except I know that I shouldn't have anything higher than x to the 6 because my answer only has an x to the 6 as the highest power. So we don't need to write more terms out than our highest power. And then our cosine of 4x was, I didn't actually write out the nice way. So let's actually go back and look at it. We simply, let me see that there. Maybe. So I'm going to write this as like, 1 minus 16 over 2 is 8x squared. So I'm gonna have 1 minus 8x squared. And then I have a plus 4 to the 4th over 4 factorial. That's kind of gross. I'm just gonna write it as 4 to the 4th over 4 factorial times x to the 4th. I guess I need the 6th. Oh, no, I don't. So do I need the 6th power here? I don't, because I know that the 6th power here has to multiply something over here. And all the things over here have powers greater than 0, which would make my overall power of that term higher than 6. And I know I should be stopping at the highest power of 6. So I don't need to write the next term here, which would be gross. It'd be 4 to the 6th over 6 factorial times x to the 6th. We don't want that. Okay, so now it's just a bookkeeping game. We got x squared times 1. Great. We get, so that's the only x squared I can get. And then I've got x squared times negative 8x squared. That's going to be minus 8x to the 4th. But I also have a minus x to the 4th over 2 times 1. That's a minus 1/2 x to the 4th. And is that looking good? It is. Because negative 8 minus 1/2 is negative 16/2 minus 1/2, which is negative 17/2. So I'm feeling good about that. Looking right. And then multiplying the x to get the x to the 6th terms, meaning x squared times 4 to the 4th over 4 factorial. Okay, let's simplify this 4 to the 4th over 4 factorial just a little bit. That's going to be 4 to the 3rd over 3 factorial, which I can handle. That's 64 over 6. It reduces to 32 over 3. Oh, I'm not excited about that, but it's okay. So x squared times that term is going to give me plus 32 thirds times x to the 6th. And then we also need to do this negative x to the 4th over 2 times this negative 8x squared. So we're going to get a positive x to the 6th, and then 8 over 2 is 4. And then finally, we need x to the 6 over 3 times 1. Now, here's what I would do. If I felt good about this, like I feel like my work looks right, I would just say, and this is equal to x squared minus 17x to the 4th over 2 plus 15x to the 6th. I wouldn't actually check that my terms there added up to 15. Even if I thought I might have made a mistake, I wouldn't check, because someone might, honestly, if I was grading this question and I saw this work here and I saw that they got 15 there, I might not check to see that those 3 numbers actually added up to 15 if I was grading it, because close enough. And I've got 100, 500 tests to grade. So something to think about there. But we can check 13 thirds plus 1/3 is 33 thirds, which is 11, and 11 plus 4 is 50. So that's good. So we could say that f of x, we should really say that f of x is approximately x squared minus 17x to the 4th over 2 plus 15x to the 6th. Not a terrible question. It's a good question. It's asking you to do all the things you would want to be able to do with the Taylor series. Okay, let's do the next one. Oh wait, there's still one more part of this. Yeah, sorry. Used to be doing exactly. Let's see. So the error of the Taylor series of f of x extended to a equals 0 in the interval between 0 and 0.1 is bounded by 10 to the negative 15. Okay. Use the Taylor approximation in part D to find the numerical value of this. I would really say you're not finding, you're approximating, right? We actually aren't finding f of 0.1. We're with an accuracy of 14 decimals. Okay. So I think he's just really telling you to plug in this number here, right? Because we know that our error is going to be less than 10 to the negative 15th, which means our answer will be accurate. So our estimate of f of 0.1 will be accurate to 14 decimal digits. I will say, with how much space is provided for this problem, it makes me feel like he wants you to write some words here and not just do like f of 0.1. Again, I'm not a mind reader. I don't know exactly what he wants, but it feels like there's more to this problem than just saying, oh, well, our f of x last time is approximately, what was it, x squared? Over 2. Can I move the paper here? X squared minus 17 halves x to the 4th plus 15 x to the 6th. So then we're just plugging in f of 0.1. So f of 0.1 should equal the natural log of 1 plus 0. Interesting. Oh yeah, 0.1 squared times cosine of 4 times 0.1, which is the thing we're being asked to find. And then we're going to say that's approximately equal to 0.1 squared minus 17 halves times 0.1 to the 4th plus 15 times 0.1 to the 6th. And it wouldn't surprise me if you should, I mean, so writing this out or finding what this actually is isn't that bad. It looks kind of gross, but it's really not. What's 0.1 squared? Yeah, question. Okay. So I feel the thing, I think you're not wrong there. I was kind of glossing over that part because I feel like he's telling us that the error is already bounded by this thing. Like, I feel like he's giving us the information that makes it so we can skip that word. Yeah. I don't know. That's a good question. Now I'm curious. Like you might be right. I've missed. Right. Well, because here's what what I'm saying is like, so our approximation before, right? Our f of x, right? I mean, I guess we could talk. Yeah, interesting. I don't just reading the way I'm reading this doesn't feel like that's what we're being asked to do. Like we could totally say that the remainder of this, and that was our 7th degree Taylor approximation, right? Yeah, of order 7. So this would be equal to the 8th derivative. But see, this is where things get problematic. Times x minus a, so x minus 0 to the 8th power over 8 factorial. I don't think we're intended to deal with this because finding the 8th derivative of this function is ridiculous. Our function is the natural log of 1 plus x squared times cosine of 4x. So I really think he's trying to help you circumvent that in this problem and just telling you, here's the error bound. I'm just asking you, given that we know the error is bounded by this small value, we can then say our approximation of this. I think he's just trying to get you to see that to approximate this, you're just going to be plugging in 0.1 to your function here. I think that seems right to me, but maybe he's going for something else. I don't really think so. I think this is what he's asking you to do. Right? He's asking you to find the value of f of 0.1, and this should be that value correct to 14 decimal digits because of what he's already told us. Yeah. Yeah, I'm not sure about like finding this 8th derivative here just seems like it would be unreasonable to ask. Not that he couldn't ask you to bound an error in some other way, just not for this question, I feel like. That seem reasonable, Madison? Like if you have other things you want to say, feel free. Yeah. I'm not saying he hasn't asked, like he certainly could have maybe he's asked questions like this before, or what you're saying before. I don't think this specific question is getting at that point. Yeah. And then we could approximate that we could actually find what this is equal to. I wouldn't unless I had time at the end, right? 0.1 squared would be 0.01, and then we'd have minus 8.5 times 0.0001, and then you have plus 15 times 0.000001. So you could probably make that into a nice single decimal without too much effort, but you shouldn't. Unless he specifically says you need to. Let's look at some of this vector stuff. Consider the 3 points, P, Q, and R. Explain why the vector U equal to PQ and V equal to PR are these things. Interesting. I kind of like that. I think the intent of this is twofold. One, it's to make sure that you have the right vectors, u and v. And two, we can easily show this by just saying, well, u should be the coordinates of q minus the coordinates of v. So if I was asked to explain this, I would literally write the following. I would say it's going to be, I'd probably actually write it like this. I would say it's q minus p, and then say that's going to be 3 minus 2, comma 0 minus 1, comma 4 minus 0. But I do think you want to show this work if he's asking you to explain why these vectors are what they are. That's 1, -1, 4. And in a similar way, we could show that v, which is equal to PR, is just r minus p, which is going to be -5 minus 2, comma 1 minus 1, comma -1 minus 0. Which is exactly what it should be. -7, 0, -1. Do you want me to find cosine of the angle? No, I don't. I think everyone like, okay, here's the formula, right? Cosine theta equals u dot v over magnitude of u, magnitude of v. I think that's something that's pretty straightforward. We can find that without too much trouble. So then let's look at the next question. A little more interesting. Calculate the cross product and find the area of the parallelogram. So, and I will point out, he does specifically ask us to find u cross v, which I have to imagine is going to come out to be negative, because otherwise it's just the answer. So we've got ijk, we've got u, which is, I just had it here, 1, -1, 4. V, which is -7, 0, -1. You should calculate this in whichever way is the most comfortable for you. My preferred way is doing it cofactor expansion, -1, 4, 0, -1, minus j times 1, 4, -7, 0, plus k times 1, -1, -7, 0. So we end up getting I times 1 minus j times 0 minus -28 is plus 28. And then plus k times 0 minus 7 is -7. So my vector is 1, -28, -7. And then the area is just the magnitude of the cross product, the area of the parallelogram. The magnitude of u cross v, which is the magnitude of this vector 1, -28, -7. And again, I'm just gonna, oh yeah. Thank you, good call. Thank you so much. This is gonna change our value here. So we should actually have a -1 minus -28. So that's gonna be 27, not 28. Thank you, yeah. -27, -27. And so then if we're finding the magnitude of this, I would just say it's going to be the square root of 1 plus -27 squared plus -7 squared. And I think you should leave it like that. I wouldn't simplify my answers unless I'm specifically asked to, or I have loads of time at the end of the test and I really feel like it's worthwhile to do. Find an equation for the plane. Okay. You've already done all the work you need to find this equation. So we know that this vector u cross v equal to 1, -27, -7 is normal to the plane pi. Pi is just the name that he has used, right? The plane pi that contains the points P, Q, and R. So once you have the normal vector, you can just use those components to get the coefficients of X, Y, and Z. So our equation, and here's the easy way to do it. The equation is going to be 1x minus 27y minus 7z equal to some constant, and then pick any of the 3 points P, Q, or R and plug that into the equation here to find the constant. So I'm going to pick the easiest one. I'm going to pick P. So P is the point 2, 1, 0. So I plug that in, I'm going to get 2 minus 27 minus 0 equals C. So C is going to equal -25. And my equation is going to be x minus 27y minus 7z equals negative 25. If you're not sure about this, or you feel like you really need to check, we could check another point just to be sure. If I check q equal to 304, that should work. So 3 minus 0 minus 28 is equal to negative 25. So that checks out. There are other ways of doing this, but this is the fastest way of doing it. All right, distance from a point to a plane. It's probably not required, but I really like drawing a picture for this. So here's my plane. Here's my point S. And I am going to find the vector from P to S. So PS is going to be, well, let's see, let's write down what P was. P was the point 210. S is the point 101. And so PS is going to be the vector 1 minus 2, 0 minus 1, 1 minus 0. And then we also need what other vector? The normal vector, which we already have. Right? That normal vector is just what it was before. It's, where'd you go? 1, negative 27, negative 7. Okay. Dot product or cross product? Is it? I never remember. Yeah, I was like, I'm pretty sure it's cross, and then you said dot. I'm like, oh wait, there's right. It's totally dot product. Dot product. So we can show why if you want, but our formula is going to be that the distance here is equal to the dot product of PS dotted with n in absolute value, right? Because it could turn out to be a negative number, divided by the magnitude of n. The PS dotted with n is going to be, let's see, I guess I could write out the things. So it's -1, -1, 1, dotted with 1, negative 27, negative 7, over the magnitude of n, which we calculated before. It's just the square root of 1 plus negative 27 squared plus negative 7 squared. So then we're going to get the absolute value of -1 plus 27 minus 7 all over the square root of 1 plus 729 plus 49, which is then going to be, let's see, 20, 19. So it's 19 over the square root of 779. I don't think you need to simplify that bottom part. I just saw it and felt like I wanted to write it more simply. You could have used any point in the plane, but when you're finding a distance from a plane to a point not in the plane, you have to have some point in the plane to as kind of a anchor point. So you have to have this vector from some point in the plane to the point not in the plane. But you could have used Q or R. Any of them would have been fine. At the end, we would get the, yeah, you won't shoot, let's do it. Let's say we used Q instead. So if we'd used Q, same idea, except now our Q is what, 304, I think? Yeah, 304. We're still going to S, which is 101. So now if we want to do, what is it? QS dotted with N over N over the magnitude of N. So really the only thing that we need to check here is that QS dotted with N comes out to be the same, right? Because the bottom should certainly be the same. So QS is going to be 1 minus 3, 0 minus 0, 1 minus 4, dotted with N, which is still 1, negative 27, negative 7. And yet things are going to turn out all right, because on top I'm going to get, ooh, are we going to turn? Yeah, negative 2 times negative 1 is negative 2. And then 0 times negative 27 is 0. And negative 3 times negative 7 is positive 21. So we still end up getting 19 over the square root of the whatever it was. So yeah, it works whichever point you use, as it should. So point to a plane, dot product, point to a line, cross product formula. And it's the same, right? It's the same type of formula. for the point to a line, it's the cross product of the vector you're going to find with the vector for the line divided by the magnitude of the vector for the line. Cool. All right. Particles moving in space. These problems don't seem too bad. Like these particle problems here, right? Finding the velocity, you're just taking a derivative. I guess I might use his notation if I was finding it. V of t is r dot of t, if you like. I mean, you don't have to, but I would. I mean, it's not too bad, except you have to use the product rule here. So let's see, we're going to get the derivative e to the negative t, which is negative e to the negative t times sine of t plus e to the negative t times cosine of t. That's the first component. Second component is going to be similar. It's going to be negative 3 e to the negative 3t times cosine of t minus, because I know derivative of cosine is going to be a negative sine, e to the negative 3t times sine of t. Finally, the last component here is going to be 5t to the fourth plus 1. Okay. Normally I wouldn't simplify this, except I know I'm going to take the next derivative. So simplifying this actually is in my interest here. So I would definitely write this as e to the negative t times cosine minus sine. And here I have, if I don't have a 3 I can factor out, so I'm just going to have negative e to the negative 3t times 3 cosine of t minus, no, plus sine of t. 5t to the fourth plus 1. Even though that doesn't seem like it's a lot better, it kind of is, because if I left it like this, I'd have to use the product rule twice for each of these first two components. I'm trying to save myself a little bit of work here for my second derivative. A of t is going to be kind of gross. So let's see, taking the derivative of this, it's going to be product rule again. Oh, yeah, gross. So I'm going to get e to the negative t, sorry, negative e to the negative t, because I'm taking the derivative of the negative t, times cosine of t minus sine of t, plus e to the negative t times the derivative of cosine minus sine, which is negative cosine, sorry, negative sine minus cosine. What's that? Oh, yeah, I think it's right here. Yeah, 100 points, extra 20 bonus points, but you can't get over 100, right? Yeah, that's not unreasonable. Same deal here. Derivative of this part's going to be positive e to the 3t times the other part, 3 cosine of t plus sine of t, and then a minus, right? So I'm taking then plus this part, so minus e to the negative 3t times the derivative of this inside part, which is going to be negative 3 sine of t plus cosine of t. Holy smokes. And then finally, the last part here is 20t to the third. It's a lot. It's kind of a gross function. Not hard to do conceptually, just making sure we keep track of all the pieces is kind of gross. Okay, so let's find the speed of the particle at time equals 0. So I want to find the speed, I'm finding the magnitude of the velocity. The speed at time t is equal to this. And here's what you shouldn't do. You shouldn't just find the magnitude. You shouldn't find the speed in general. You should just plug in t equals 0 to velocity and then find the magnitude of that. So the velocity at time 0 is, okay, let's take a look here. It's going to be e to the 0 times cosine of 0 minus 0, comma, negative e to the 0 times 3 times cosine of 0 plus sine of 0, comma, 5 times 0 to the fourth plus 1. Right? We definitely don't want to write out the velocity of just this function. I think that's definitely terrible. So this velocity vector is just going to be 1, comma, -3, comma 1. And then the magnitude of that is not terrible at all. It's just the square root of 1 squared plus -3 squared plus 1 squared, which is the square root of 11. Definitely the way we should do this problem. 1000%. What's the next one? I feel like it's the same question, just with a different point. No, it's not. Just thought it was. Okay. Anyway. Oh yeah. Okay. So consider the sphere. Sorry, you can't see that. Consider the sphere centered at 0, 1, 3 with a radius of 5. That's how I would read that. Decide whether the particle is inside or outside the sphere at times t equals 0 and t equals 10. So what we're really asking here is at time equals 0, is the particle within a distance of 5 to the center or not? Well, let's find the position at time equals 0. So r of 0, I guess I should go back down and find my function. Let's just do this. Great. So r of 0 is going to be e to the 0 times 0, e to the 0 times 1, and 0 plus 0 plus 3. So now we have to ask ourselves, okay, what is the distance? Okay, here's a dumb question. What's the distance from this point to the center of this sphere? What's the center of the sphere? Right. So what's the distance? 0. So right at the beginning of this particle's movement, the particle starts at the center of the sphere. So definitely at time equals 0, this particle is inside the sphere. It's at the center. My guess would be, because if I was asking this kind of question, I would try to ask it in a way where one of the answers was yes, it was inside, and one of the answers was no, it's not inside. My guess is going to be that the next one's going to not be inside, but let's find out. So r of 10 is going to be gross. It's going to be e to the -10 times sine of 10. E to the -30 times cosine of 10, and 10 to the 5th plus 10 plus 3. So here's what I would point out. I'm not actually going to find the distance between these two things. I'm just going to observe that it's bigger than 5. So let's see. If I want to find the distance between the center 0, 1, 3 and what r of 10 is, because I don't really want to write it again. I know how to use the distance formula. The distance is going to equal square root of, I wouldn't even pay attention to the first two terms. It's going to be 0 minus e to the -10 times sine of 10 squared, which is probably pretty small, right? E to the -10 is a pretty small number, like extremely small actually. And then same deal here, 1 minus e to the -30 times cosine of 10 squared. But then at the end here, we have plus 3 minus 10 to the 5th plus 10 plus 3. It doesn't even matter what these two terms are. This part here is about 10 to the 5th. And the square root of 10 to the 5th is, well, 10 to the 5th is 100,000. Square root of 100,000 is way bigger than 5. And that's all we really care about. It's way, way bigger than 5. So definitely outside. So I feel like he was trying to make it relatively obvious, right? If you did the work, you should be able to see without too much effort that, oh yeah, that value is much, much larger than the radius of this sphere. Right, because it's 25 right there. Yeah. So that's how we tell if something's inside or outside the sphere. Is it the distance that's further away from the center than the radius? Compute the distance from the initial position of the particle to the line given by the intersection of the two planes x equals 0 and x equals 2. I'm confused by this question. I feel like there might be a typo, unless I'm reading it wrong. The way I'm reading it, he's talking about where the planes x equals 0 and x equals 2 intersect. But those planes don't intersect, they're parallel. Right, x equals 0 is the YZ plane, and x equals 2 is go 2 units forward, the plane parallel to the YZ plane. I think he meant one of those was either a Y or a Z. Yeah, let's just pretend. So let's pretend it's Y equals 2. So then we're looking at, oh, okay, so if this is my line, x equals 0 and y equals 2, how do I write the equation of that line? Do I need to write the equation of the line? Yeah, I kind of do. Well, let's think about it. Think about 3D space for a second. If x equals 0, I'm on the, I can't move forward or backwards, right? Right? I'm done moving forward or backwards. X is 0. So I can only move left to right or up down. But then if y equals 2, now I can't move forward or backwards or left or right. What's the only direction I can move? Up or down. So if x is fixed and y is fixed, the only thing that's free is z. And so this line equation is essentially, my line is given by, well, I've got some initial point like x is 0, y is 2, and z is 0. And then I'm adding on any multiple of the vector 0, 0, 1. Because the z direction is the only direction I can actually move in. Or if you prefer, we could write our equation as x of t equals 0, y of t equals 2, and z of t equals 1 times t, or 0 plus 1 times t. So z can be anything depending on the value of t. So our line's going straight up. And then we're trying to find the distance from the initial position of our particle to this line. So really, this is a very kind of convoluted way of just asking you to find the distance from a point to a line. So here's our line drawn in not the right orientation, but I don't care. And the vector of travel is going to be 0, 0, 1. And then the point we're talking about is our initial point, which was 0, 1, 3. You do need a point on the line. And the point's going to be just the point 0, 2, 0. You could pick something totally different. You could pick literally 0, 2, anything you wanted for the third coordinate. But I'm going to pick 0, 2, 0. And then this is my P, this is my S. We do the usual thing where the distance is equal to the magnitude of the cross product of PS with V over the magnitude of V. Which is nice because the magnitude of V is just 1. It's really just going to be whatever PS cross V is going to be. All right, PS is going to be 0 minus 0, 1 minus 2, 3 minus 0, and V is going to be 0, 0, 1. So then quickly we do a cross product. There's lots of zeros here, which makes things pretty nice. So we're going to get, let's see, I times -1, 3, 0, 1 minus j times j, that's going to be a 0 there for us. And then plus k is also going to be a 0 there for us because we got 0, 0, 3, 1. I'm sorry, -1, 0, apologies. That just ends up being -1 times I. And the magnitude of that is 1. So it looks like here the distance between the point and the line is just 1. Seems a little surprising, but I guess it is what it is. Cool. So we only have 2 minutes left. So let's skip these partial derivative questions. They're not too bad, but I do want to look at the last page just for a second here. I do think it's worth looking at. So this converges. Well, this looks similar-ish to a P series, except terrible, right? But I would definitely, if I was trying to show this converge, I would be doing a limit comparison with n squared over n to the alpha. And as long as alpha is more than 1 bigger than 2, then you're going to get convergence. So essentially, we need alpha to be greater than 3. We can definitely find the value of this infinite sum, right? This is just first term over 1 minus r. I think this is an interesting question. The intersection of these two things might be something, it might be nothing. How do we tell? I don't know. How do we tell? Good question. How do we tell here? Well, what's my center? My center is 4, 3, 0. I guess, oh yeah, okay, here's how we do this one. If you wanted to tell here, you would say that I need to find the distance from my center of my sphere to the closest point on the plane. And then if that distance was less than the square root of 10. By that, you could step. Yeah. And then midpoint's no problem. Radius of convergence of this shouldn't be too terrible.
Can you do the B?
The B?
Yeah.
Sure. So if I look at this here, if I write out the series here, what is my first term of this series? Right. And then what's my next term? And what's my next term? Right. So this is going to add up to the first term divided by 1 minus, what's my ratio? Not 5/7. So the ratio is what you're multiplying by each time to get to the next term.
Oh,
Exactly.
okay.
So then this is going to be 5/6/7, which is 5 times 7, 6, which is 35/6. Now, fun fact about this one. This one's easier than I made it sound because the center of the sphere, if you plug in that point into this equation, you get 4 plus 6 minus 0, which is equal to 10. So the center of the sphere is exactly a point on the plane. So then if you have a plane cutting a sphere through its center, or really cutting a sphere at all, what kind of shape are you left with? Yeah. Well, so
But if it's a ball,
right. So personally, you are right. And I will point out, is this a sphere or is this a ball? It's actually a ball. And the thing that makes it a ball is the less than or equal to part. Right? The less than or equal to means you're getting all the points inside. So you're right. We shouldn't be getting a circle, we should be getting a disc. Good call. I missed that for sure. It's easy to miss.